film number 1 on the TCP IP protocol stack, or the so-called Internet Protocol Suite. And the Internet Protocol Suite, TCP IP, it's a set of communication protocols for Internet and similar technologies, which means that you can use this, of course, when you communicate something onto the Internet, but you can also use it, for example, for industrial applications where you want some industry components to communicate with each other, for example, a sensor and an actuator, and with data that is never sent onto the Internet, but still use the same technology. So therefore, TCP/IP is not only for things that are about to go onto the Internet, but for similar technologies as well. It has its name from the two most important protocols, TCP and IP, but it holds many more protocols than those two. For example, FTP, HTTP, SMTP, UDP, and so on. The P's here are for protocol. File transfer protocol, hypertext transfer protocol, and so on. Many protocols in that system. As mentioned earlier, the TCP/IP architecture is similar to the OSI model, but it only has 4 layers. Fortunately, the division lines between the 4 layers in the TCP/IP model matches the one in the OSI model, apart from that they have bundled layer 1 and 2 and also the top 3 layers into the so-called application layer. 1, 2 is the network interface layer, then you have internet layer, transport layer, and application layer. So the division lines here are fortunately the same. So here is a list of the different protocols that you will find, and there are even more, as you see. In the network interface layer, which is also called the link layer, you have things like ADSL, XDSL, ISDN, and for example ARP and MAC and others. You have here IP for IP addressing, for example, TCP, which we'll come back to later, and here you have application specific protocols, like for example this one, which is for file transfer, and this one, which is for domain names like google.com, for example. The application layer contains application-specific protocols. The layer number 3, transport, the most important here is TCP. TCP, Transaction Control Protocol. That is the protocol that makes sure that large messages are split into smaller packets, and the packets are ordered, and if they are missing at the receiving side, the receiver knows how to ask for a resending of a given packet in order to be able to collect the packages into one large message in the end. And then send acknowledgements that all the packets are received, the communication was successful, and so on. So that's what the transport layer does. Of course, when you do that, you have to have standards for, or protocols for, how to label the packets with packet number and how to request missed packages. Also, adjusting transmission rate. If the number of packet losses, the percentage loss is very high, then the transmission speed should go down in order to get less loss on the line. Layer number 2, going down here on the model, the internet layer is for addressing and routing protocols. So that is for global addressing, how you send a message onto the network, how it finds its way through the internet to the receiver at the other side. And then you need addressing standards, because you need to send who you want to send the packet to and who the sender is, So both sender and receiver must be a part of that packet. The TCP IP link layer, or the link layer, network interface layer, it's also called, holds protocols that consider point-to-point connections. So it's from the computer to the nearest switch, from the switch to the router, from the router to the next router, from the router to the gateway maybe, and from device to device all the way along the line. So you have different link protocols for every link in the chain of network devices. When you have a message here generated by the application, let's say that you have a mail, you want to send a mail, and that is your application, and the application generates a message. The transport layer has protocols that defines how a large message is supposed to be split into smaller packages, and the packages are given a TCP header if the TCP is the protocol that is used. So the packet is given a header telling which packet it is, the number in the chain or in the set of packets that forms the entire message. So for example, packet number 16 of 58, for example. The packet is now called a segment. So it's a segment which contains the packet data and the header. When that packet with the header and everything is goes further on its way onto the internet, the protocol on the internet layer gives it an IP header, and the IP header has information about who the sender is and who the receiver is. So sender and receiver. Then the protocols on the link layer adds even more information, and that's the frame header and frame footer. And that is, for example, error checkings to see if the packet is alright. Also the destination to the next network device. And when the next network device receives the frame, which is now, the packet is now called a frame, when the next device receives this, the frame header and footer is removed and replaced with a new header and footer containing the address to the next device in the network. So you have here peer-to-peer, which is from the host or the sender to the final receiver, and then you have individual devices here like routers, and the router here will change the frame header and frame footer when it sends the message to the next router.